Good morning, everyone. This is Melody Rondeau, and I'm going to be showing us how to graph quadratics using standard form. You guys can go over the learning intention and success criteria. They are right there. I'm going to go ahead and get us started. So standard form of a quadratic looks like this. You might want to pause here to copy those down. The first one with the y equals, that's equation form. The second one is in function form where we see f of x, but you'll notice the rest of it looks the same. It should look really familiar since we've been doing quadratics for a while now. The vertex. To find the vertex of a quadratic, remember that's the highest point or the lowest point, called the maximum or the minimum. We're going to use this fabulous formula. It is negative b over 2a, comma, and a blank. This right here is how we find the x value, and this here is how we find the y. Well, that is, to find the y, we're going to actually find x first, and then we're going to plug it in. So we're going to find x first, then plug it in to find y. There you go. So this little formula, negative b over 2a, that's how we're going to find x. I'm going to make sure that's clear. That's not a z, that is a 2. So it's negative b over 2a. All right. The next thing we have are the a values. So that a, which is the in front of the x squared number, we have a couple of things that the a value tells us. If it's positive, then the parabola opens up. Remember, parabola is the word for that U-shaped graph, what the graph looks like. So this, again, if it's positive, the parabola opens up. And then if it's negative, that parabola is going to open down. Opens down. Also, things to keep in mind, before we get to axis of symmetry, if the parabola opens up, that means that we have a minimum for our vertex. And if the parabola opens down, that means we have a maximum for the vertex. All right. Let's go on to axis of symmetry. Axis of symmetry is going to be this fabulous equation, x equals negative b over 2a. And I do want to point out it's the entire equation. X equals, you can't just say the negative b over 2a part, it's the whole thing. And we'll talk about what the axis of symmetry is in just a oh no, we did talk about it already. The axis of symmetry being that line that divides our parabola into two equal sides or symmetrical parts. The last thing here, the y-intercept, we're going to find that by plugging in 0 for x. And when we do that, if you look at our equation up at the top here, if we plug in 0 for the x squared and the x, we're going to end up with this is going to become 0 times a number, so this is going to be 0. Then another 0 times a number is going to be 0. I'm going to be left with c. So we would fill in c. So instead of actually solving to find the y-intercept, we can actually just say we know in this form that the y-intercept is found at 0, comma, whatever that c or constant is. So those are the parts of standard form. Now let's take a look at identifying some of those key features. So example 1. Identify key features of the quadratic function. We're looking for direction, vertex, axis of symmetry, and y-intercept. All right, so starting with direction, that comes from our a value. So in this problem, what is the a value? It is negative 1. We see that in front of our x squared there. Since it is a negative, sorry, I'm going to squish this underneath. Since it is a negative, that should tell us something we just mentioned on the last slide. A negative a value means this opens down. So that's the first thing, that's our direction. Then we have vertex, because it opens down, so I'm just going to draw a quick little sketch. We know that our vertex is going to be a maximum point at the top, but this is asking us to actually find the vertex. So let's go ahead and do that. Sorry about that. Let's get that to go away. There we go. Nope. Okay. All right, so to actually find the vertex, we're going to do this little fabulous formula that's basically the x value equals that negative b over 2a. And I'm going to plug in from my quadratic formula. So up here, my b value was 6, and we already have the a is negative 1. So I'm going to say negative and then the 6 over 2 times negative 1. And then I'm going to simplify. That gives me negative 6 over negative 2. And then simplify. Negative 6 divided by negative 2 is 3. I then take the x value, and I'm going to go, not to the next screen, sorry guys. I'm going to go plug it back into my function. So I'm going to say f of 3 equals, and I'm going to plug in. So every x becomes a 3. Notice the negative was in front, so it stays in front. Then I have plus 6 times 3, and then plus 2. All right, so order of operations says we do parentheses and then exponents. So my parentheses, there's nothing to simplify inside. My exponents, I'm going to do 3 squared first. This negative out here is just going to stay out here. So this is really negative, and then 3 squared is 9. And then I have plus 6 times 3 plus 2. Then after parentheses, exponents, then we do multiply. So here, negative 1 times 9 is negative 9. 6 times 3 is 18, and then I still have that plus 2. Then I do addition. I have no division. Sorry, parentheses. Let me write this down for us as a reference. PEMDAS, or please excuse my dear Aunt Sally. Whatever way you remember it, but we have parentheses, exponents, we did multiplication, division, there isn't any, and then addition and subtraction left to right. Remember, these two go together. So multiplication and division left to right, addition, subtraction left to right. All right, so negative 9 plus 18 is 9, plus the 2 gives me 11, so my vertex is at 3, 11. Remember, 3 was the x value, and this f of 3 represents the y value. All right, so we've made it through direction and vertex. The next thing we need is axis of symmetry. The axis of symmetry is actually this equation we use up here to find our x, so our axis of symmetry is actually the same. So axis of symmetry, because it always goes through the vertex of our parabola. So it's going to be x equals 3. There's our axis of symmetry. And the last thing we need is the y-intercept, which should be super easy. We put 0 for x, and then we go back and find that c value, which was 2, and there's our y-intercept. So those are kind of the key features when we're in standard form. Finally, let's see how to graph this. So graph the quadratic in standard form. We're going to identify the vertex and the y-intercept. So pretty much we want to do that right away, go to finding the vertex. So again, we're going to start with x equals negative b over 2a. And in order to do that, we need to identify, whoopsie, not go backwards, what our a, b, and c are. It's helpful. So I would say x equals negative. My b value is 8. And then 2 over my a value is negative 2. Then I would simplify negative 8 over negative 4. 2 times negative 2 is negative 4. Then divide. Negative 8 divided by negative 4 is 2. Then I take that back and plug it in to the original equation. So this time it's y equals. I have negative 2. Replace craziness here. Hold on. There we go. Sorry about that. Okay, I have negative 2, and then I'm going to replace the the x with 2, which we just found, then squared. Sorry about that. Okay. Squared. There we go. Okay. Negative 2 times, replace the x with 2, squared. Great. Moving right along. Plus 8 times 2, replace the x again, and just ignore that. And apparently it won't let me just ignore it. Fantastic. Let's go to the last thing, minus 5. We'll get through this. Here we go. Then exponents and parentheses first. So the negative 2 here stays. Then I do 2 squared, which is 4. and then 8 times 2 minus 5. Then I do multiplication and division. In this case, I only have multiplication, so minus 8 and plus 16. So negative 2 times 4, that's how I got the negative 8. 8 times 2 is 16. And then we go through and add and subtract across. Negative 8 plus 16 is 8, minus 5 is 3. So I get a vertex at 2, 3. I'm going to go put that on my graph, over 2, up 3. And as soon as I put my vertex down, I'm going to actually graph my axis of symmetry, which I know always goes through the vertex, just like that. So there is my next page, axis of symmetry. Okay. And we're going to use that to help us graph. It's going to be really important in a minute. Then I have my y-intercept I'm asked to find. So the y-intercept, that's easy. It's going to be 0 for x, and then that c value, which we are already identified, is negative 5. So over 0, and then I'm going to go down 5. There we go. And here's where that axis of symmetry comes in handy. As long as we have a point on one side of our parabola or of our axis of symmetry, we have to have a matching point on the other side. So we're going to match that negative 5 point. So if we have a point on the left, it has to match on the right. That's called using the axis of symmetry. And once we have at least those 3 points, we can go ahead and sketch our parabola. We're going to do as smooth of a curve as we can. This should not be pointy. It should be smooth and curved, kind of like a U, like that. And we have graphed our first parabola. All right, on to example 3. One more time. This time we're in function notation, but the rules are the same. I'm going to start by identifying the vertex. Hold on. Maybe. There we go. Cool. All right, here we go. Sorry about that. All right, so my vertex, we're going to start by finding the vertex, which is starting with x equals negative b over 2a. Again, in order to do that, we have to go through and do a, b, and c. And here, just a reminder that that a is going to be a 1. So here goes, x equals negative. This time be careful because our b happens to be a negative value, but that first negative is in front, and then we have negative 6 for the b. All over 2, and then times 1 for the a, and simplify. Negative times negative 6 is 6. 2 times 1 is 2, and I get 3. Then I'm going to go back and plug that into my equation. So this time I'm using function notation, so I replace the x with 3. And then I have 3 squared instead of x squared minus 6 times 3 and plus 5. And then simplify 3 squared. Remember exponents parentheses first, so 3 squared is going to be 9. Minus 6 times 3 plus 5. Then I go through and do any multiplication and division. Remember this right here is multiplication. So 9, and then negative 6 times 3 is negative 18 plus 5. And simplify. 9 minus 18 is going to be negative 9 plus 5 is going to be a negative 4. Sorry, just making sure the math was good there. Yep, negative 4. And so then our vertex is going to be at 3, negative 4. And then we're going to do our y-intercept again. Let's start with vertex on the graph. I'm getting ahead of myself. Over 3, down 4 for the vertex. And then we're going to immediately, as soon as we put the vertex in, we're going to put in the axis of symmetry. Sorry, not happy with that little arrowhead. Try that again in a minute. All right, so axis of symmetry, which always goes through the vertex, like so. The y-intercept is at 0, and then we go back and find that c value. In this case, it is 5. So I'm going to put a point at 0, 1, 2, 3, 4, 5. And once I have a point on one side of the parabola or one side of the axis of symmetry, I have to match it on the other side. So this is 3 boxes away, so I go 3 boxes away. and there's my matching point, so it is symmetrical. And then again, connect with a nice U-shaped curve, something like that. The last thing, which I didn't mention on example 2, but I would like you guys to be checking, is once you have it graphed, double check. If I go back and look at my A value, was it positive or negative? In this case, it was a positive 1, which means my parabola should be going up. It does, so that's kind of a quick check to make sure you did it correctly. Let's go back to example 2 and look at that. If I look at my A value, is it positive or negative? It's negative, so that means my parabola should open down. It does, so we are in good shape. That, my friends, wraps it up for today for graphing our quadratics in standard form. Thanks, bye-bye.